Welcome to Ford Tech Talk. In this series, we'll focus on tips to help you fix Ford and Lincoln vehicles right the first time. Have your customers come in with questions about white smoke coming from the tailpipe of their Ford diesel-equipped vehicle? Excessive white smoke from the tailpipe may be the sign of a larger issue. Some white smoke from the tailpipe under certain conditions is considered normal. For example, you might see a little when warming up the vehicle on a cold day, or during some modes of regeneration, which we'll talk about later in this video. If your customers sometimes have white smoke concerns, though, this video will help you determine what's causing the issues. We're going to take a look at several possible causes, starting by ruling out the easiest components to check first and moving to the more complex repair diagnostics. Before you begin any repairs, verify the customer's white smoke concern. Then, use the Integrated Diagnostic System, or IDS, to identify any diagnostic trouble codes, or DTCs, that may be present in the Powertrain Control Module, or PCM. Next, check the publications for any technical service bulletins or special service messages on white smoke. In some older 6-liter engines, customers can experience white smoke after a cold engine startup or one of these DTCs. You can find a complete listing in Ford Technical Services Bulletin 924-3. If that combination occurs, refer to the Calibration Content Technical Services Bulletin for additional details and reprogram the PCM using your updated IDS scan tool. It will automatically update the necessary modules to the latest settings. Before you tear into the engine, start by checking for customer modifications. These add-ons may cause a diesel engine to start producing white smoke, and they're often easy to spot and to remove. Ford Motor Company does not endorse any of the following modifications being made to its vehicles. First, check for exhaust modifications the customer may have made. Many Ford diesel-equipped vehicles built after 2007 have a diesel particulate filter or DPF system that traps the diesel particulate matter, the black soot produced by the engine, and burns it down to ash in the regeneration process. These engines have a special exhaust tip that can contribute a minimal amount of white smoke. It disperses part of the exhaust, helping the system to function properly. Changing this tip can create a white smoke issue and alter the function of the exhaust system. Then, check for intake modifications the customer might have made. Changing the type of charge air cooler or performing any modifications to the air intake system to provide increased airflow to the engine could affect the temperature of incoming air and create too much condensation. That could affect combustion, which could produce white smoke from the tailpipe. If you don't find any modifications, check the coolant and oil levels to see if they're low. There could be an external leak causing low coolant or an internal leak causing coolant consumption, leading to white smoke. A low oil level and white smoke could suggest a leaking turbocharger. But if you're still not finding the cause of the white smoke, the next item on the checklist is the charge air cooler. This is generally not the cause in a 6.0 diesel, where the charge air cooler is smaller and doesn't condense the same volume of air. But in other diesel engines, moisture can collect in the charge air cooler and get carried into the intake manifold and engine. When you combine a heavy RPM load with certain drive cycle conditions, such as heavy acceleration, this moisture can move through the intake and burn off, producing excessive white smoke. In a 6.4-liter diesel, there is a special set of circumstances to watch for that can indicate a fault with the charge air cooler. When the white smoke only occurs in high humidity or rainy conditions, and only during moderate to heavy acceleration after 20 minutes of steady-state driving, with no other DTCs present, and you've ruled out excessive regeneration as the cause, then the charge air cooler is likely the cause, due to an older level part. Check the charge air cooler part number to see if you need to perform the TSB. In the 6.7-liter, you'll need to check both the primary and secondary cooling systems, which doubles the items to check. Is there a significant loss of coolant and liquid running out of the tailpipe? If so, there's likely an internal leak in the exhaust gas recirculation, or EGR cooler. And visually inspect for any obvious external leaks around the EGR cooler, but take care not to pressurize the system while checking. That could cause a hydrolock, as coolant may flow into the cylinders when the system is pressurized. On a diesel engine, 3 different systems work together: the intake, the exhaust, and the cooling system. The EGR cooler is the most likely cause of coolant intrusion into either the intake or the exhaust system. Check the hoses first. If you don't find any external leaks, you'll want to dig deeper. Internal coolant usage can be caused by EGR internal component leaks. For a 6-liter, the EGR valve can be removed and the intake inspected for coolant. For a 3.2-liter, the exhaust back pressure or EBP sensor can be removed at the rear of the horizontal EGR cooler and the port checked for steam or coolant. For the 3.0-liter, 3.2-liter, and 6.7-liter, the EGR cooler will need to be removed and bench tested to confirm any internal leaks. If the fluid in the exhaust is engine oil, you'll need to inspect the turbocharger for a possible seal or bearing failure or both. If the cooling system and turbocharger check out and the engine will run or rotate, you'll want to check the fuel system using the IDS. Check the fuel correction PID data with the IDS scan tool. It should show the fuel correction adjustment that you need to have equal cylinder contributions. If a cylinder is contributing too much, the PCM will make a correction by lowering the fuel correction value. This step happens in an effort to equalize contribution across neighboring cylinders. If a cylinder isn't contributing enough, the PCM will make an adjustment by increasing the fuel correction value. It's these adjustments that help provide a smooth idle. If the PCM is significantly lowering the fuel correction value and the cylinder in question is still contributing too much, that means there's an injector leaking. This situation will likely lead to fuel knocking. Keep in mind, a diesel engine runs on what you feed it. The more fuel, the faster it goes. Give your Ford, Lincoln, and Mercury customers impressive performance by choosing Motorcraft Air Filters. Motorcraft Air Filters help eliminate dirt particles that can enter through the air intake system and create an imbalance in the precise mix of air and fuel to the engine. The dry-type cleaner elements are chemically treated to withstand oil and moisture damage. Made to fit each application, they test to a 98.5% efficiency standard in coarse dust testing, with excellent dirt-holding properties. And when you're choosing parts for all of your repairs, remember that Motorcraft parts feature a 2-year, unlimited mileage warranty. That's all for this post. Thanks for watching. Check out the rest of our series of installation and repair tips for Ford or Lincoln vehicles. For more information on Ford or Motorcraft parts, contact your Ford or Lincoln dealer or distributor, or visit FordParts.com.